Hey everyone, welcome to another Edexcel International A Level Maths past paper video. Today we're going to talk about the E3 exam from the October-November 2024 series. So let's jump into the paper. Question number 1. Solve for theta between 0 to 360 degrees the equation 3 tan squared theta 7 secant theta minus 3. Now, this is a quadratic equation, but notice that the terms are different. So either we make them all in tan or in secant squared. So easier way is to convert tan squared into that. So because we know that tan squared theta would be equal to secant squared theta minus 1. Because 1 plus tan squared theta is secant squared. So the equation simply becomes 3 tan squared theta plus 7 secant theta minus 3 can become 3 secant squared theta minus 1 plus 7 secant theta minus 3. So 3 secant squared theta plus 7 secant theta minus 3, this becomes minus 6. So when we make this equal to 0, this is identical to this being equal to 0. So 3 secant squared theta plus 7 secant theta minus 6 equal to 0. Now we need a product. Let's try using the sum and product rule. You can try a different method of sum and product, but more or less they will be the same. So you have a product, you have a sum, and you have this. So there's only one way to get 3, but there is more than one way to get 6. So 2 and 3. So 3 times by 3 is 9x, and this is 2x. So only way you're getting a positive if this is negative. Right, okay. So you're getting 3x minus, 3 secant theta minus 2 and secant theta plus 3 equal to 0. Now remember, secant theta is the reciprocal of cosine. So secant theta, like the magnitude of the secant theta, is always greater than equal to 1. Okay, because it exists sort of like this. So it does not exist between 1 and minus 1. So any value that comes into that form, we will disregard. So secant theta equals 2 over 3. Obviously, this will not give us any solutions because the reciprocal of that will be 3 over 2. So we will not be able to get any solutions from this. However, the other one, secant theta equals to minus 3, will lead us to cos theta equals to minus 1 over 3. And now we can actually solve this. So when we do, this is in degrees, right? The cos inverse of 1 divided by 3, you get 70. So basically we know that the cosine graph goes like this. So the negative minus 1/3 will actually get us 2 solutions. You can use the cos diagram also. So cosine is negative in the second quadrant and in the third quadrant. So whatever this is, 70. So this is going to be 180 minus 70, because this is 180, 70, and 180 plus 70, which it would be right over here. So 180 minus 70, 70.52, and 180 plus 70.52. Right, okay, so theta would be 180 minus, so 109.45 degrees, and the other one would be 250.5 degrees. Alright, so that was question number 1. Let's move on to question number 2. Question number 2. Figure 1 shows the sketch of the curve with equation x is equal to 2y squared plus 5y minus 6. Find dy by dx in terms of y. So what we can do over here is we can start by taking dx over dy, 2y squared plus 5y minus 6. So dx over dy will be equal to 4y dy by dx sorry, dx over dx. I just forgot about that. Right. Plus 5 dy by dx, and 6 would be 0, obviously. So basically this is going to be 1 equals to dy by dx equals to 4. So no, multiplied by 4y plus 5. So dy by dx would be 4y plus 5. Okay. The point P lies on the curve and is shown in figure 1. Given that the tangent to the curve at P is parallel to the y-axis, find the coordinates of P. Right. So if we do dy by dx, so at P it would be infinite. So what we can do is the reciprocal of that. So for part B, we can instead do dy by dx over dy at P is 0. Rather than saying dy by dx is infinite, we say dx over dy is that. So basically, 4y plus 5 equal to 0. So y would be minus 5 over 4. And we also need the x, so therefore x would be 2y squared plus 5y minus 6, just to make sure that this is the equation right. 2 minus 5 over 4 squared plus 5 minus 5 over 4. Right, okay. And minus 6. So 25 over 16 minus 25 over 4 minus 6, so 50 over 16. 4 times by 4 times by 4, so this is 100 over 16, and 16 times by 6, 96 over 16. So you will have 50 minus 100 minus 96, so this is minus 146 over 16, so divided by 16, this, oh no, 73 over 8. So the coordinates of P are x is equal to minus 5 over 4 and y equals to minus 73 over 8. Sorry, it's the other way around. I just realized that this, what we found was the x. So x is the minus 73 over 8 and this is minus 5 over 4. Right. And this is question number 2. Let's move on to question number 3. Okay, so question number 3. Figure 2 shows a sketch of the curve with equation y is equal to f of x, where 2x squared minus 10, where f of x is 2x squared minus 10x. So before even going into that, we can see what that means, that this is 2x x minus 5. So that would mean that this roots are x is equal to 0 and x is equal to 5. So 0 and 5. That means the line of symmetry is at 5 over 2. Right, okay. So let's see what we have. So solve the equation y is equal to f mod of x equals to 48. Okay, so f mod of x, what it does, it actually creates a reflection of the everything that is on the right side of that. Because the mod x means anything negative value will be turned into positive value also. So basically, for example, if you want f of minus 5, you will actually be getting the same value as x of 5. So basically, you will have sort of like this value, and you will not have this value. Right, so it's basically sort of like a W type situation over here. Right, okay, and this is equal to 48. So basically, since the left and right side of the y-axis are going to be identical, so whatever x value we have over here will be same as over here, but on the negative side. So for part A, 2x squared minus 10x equals to 48. We can turn this into a quadratic equation. This is already a quadratic equation, but 2x squared minus 10x minus 48 divided by 2, 5x minus 24. 8 and 3 can give us 24, so this can only happen if 8 is the negative and 3 is positive. So either you get a value 8 or minus 3. So this particular value would have been minus 3 over here, but we don't want this because this part of the graph doesn't exist for us. So this is the 8, so obviously this would be minus 8. So final solution, f mod of x equals to 48. Final solution would be x equals to plus minus 8. Right, okay. Find the set of values of x for which f of x is greater than or equal to 5 over 2x. So remember, so see this, that this is a straight line equation. So 5 over 2x means that this is, this is a straight line which is passing through the origin. And mod of x, what it does is, come on. Okay, I'll correct that in a second. Right, okay. Now, mod of x, what it does is that you will have the same graph, but the negative part will be reflected upwards, and this would be your f of x whole modulus, and this is your y equals to 5 over 2x. Now we need where the function is greater than 5 over 2x, so basically we need the values these. Okay, so only at this place it is less than. So if we can figure out what this value is and what this value is, we can figure that out. So how do we do that? Two ways to do this. So remember, this is mod. We need the same value in the x value, so basically what we can do, we can replicate that with the f dash, the negative of y is equal to that. So this would be minus 5/2x. Okay, right. So one way to do this is to square the values, square the two sides. But one side is already quadratic, so we don't want to do that. So basically, simply what we do, we figure out where, so where f of x is greater than positive 5/2, and where f of x is less than or equal to minus 5/2x. Okay, simple reversal. So basically this would be the same, this would be the same value over here. Like this. Right. So if we can find out this value, we can, the x value would be the same. And also this value, because this value is also meeting. Right. So for the positive one, we need both positive one and the negative one. So let's figure this out. You have 2x squared minus 10x greater than or equal to 5x over 2, and you have 2x squared minus 10x less than or equal to minus 5 over 2x. Now the process for solving them would be almost identical. We multiply both sides by 2. You get 4x squared minus 20x greater than or equal to 5x. This would get us 4x squared minus 5x minus 20x 0. So basically this is 4x squared minus 25x greater than or equal to 0, and this one is 4x squared minus 20x less than or equal to minus 5x. So this would become 4x squared minus 20x plus 5x less than or equal to 0. So basically this would become 4x squared minus 15x less than or equal to 0. So both of them are in a way quadratic. So if we can find out the critical values from this, so this would be x 4x minus 25, and this would be x 4x minus 50. So one value is x. We are already getting x over here, so x is a trivial answer for us. So this would mean that 4x minus 25 is greater than 0. This would mean that 4x minus 15 is less than 0. Okay, technically, that's not the only case over here. However, because if you're getting a product greater than 0, this could mean that either x is both of them are greater than 0, or both of them are less than 0 also. So either way you can do that. However, this would be x greater than or equal to 25 over 4, and this is getting us less than or equal to 15 over 4. So reconciling this is the 25 over 4, and this is, let's use a different color to illustrate, this is 15 over 4. Okay, So the mod of x, so what we got over here from the 25 over 4. So yeah, you see the f of x is actually going greater than that, beyond 25 over 4, and less than this value, 15 over 4, you have f of x greater than 5 over 2x. So basically that's it. So either x is less than or equal to 15 over 4, or x is greater than or equal to 25 over 4. Right, so this was this question. Let's move on to the next one. Question number 4. The number of bacteria on a surface is being monitored. The number of bacteria n on the surface t hours after monitoring began is modeled by the equation. Okay. Find the initial number of bacteria on the surface. So when t is 0. So when t is equal to 0, you will have log n equal to 0 plus 2. So basically log n is going to be 2. Basically that means that n is equal to 10 raised to power 2, which is 100. Okay. Initial. Show that the equation of the model can be written in the form this. Okay, so we have log n equals to 0.35t plus 2. Okay, so when we reverse this, basically doing the 10 raised to power and 10 raised to power this thing, you get n equals to 10 raised to power 0.35t times by 10 raised to power 2. Okay, so this one on the other hand can be written as 10 0.35t times by 100. So 10 raised to power 0.35. This is this value. 2.2. Wait a second. How much we need? Give the value of a and b. Give the value of b to 2 decimal places. Okay, so 2 decimal places would be 24. T times by 100. So therefore n can be written as 100 times by 2.24 raised to power t. Hence find the rate of growth of bacteria on the surface exactly 5 hours after monitoring began. So find the rate of growth of bacteria exactly 5 hours after the monitoring began. We can take the So n equals to ABT. So B part, you have this, so we need dn over dt. So we know exactly how to handle this differentiation. So 100 will come as it is. This will also come as it is, but we will multiply with the ln of 2.24. Okay. So we have 100. Wait a second. We just need at 5 hours after, right? So we can actually just first plug it in. So 100 ln 2.24 times by 2.24, 5. So 100 ln 2.24 times by 2.24 raised to power 5 So we get 4, 5, 5, 0. 3 significant figures. Why? Because it's given in the instructions to give the answer in 3 significant figures. 3 significant figures, right? Okay. Now, going back. Right, so that's for this question. Let's move on to the next question. Question number 5. Show that sine 3x can be written in the form where p and q are constants to be found. So this is straightforward. Sine 3x can be written as sine x plus 2x. Now, when you do the compound angle identity, you get sine x cos 2x plus cos of x sine 2x. Cos 2x in terms of sine is 1 minus 2 sine squared. So sine x, 1 minus 2 sine squared x, plus sine 2x can be written as 2 sine x cos of x. This becomes sine of x minus 2 sine cubed of x plus 2 sine of x, and cos squared becomes 1 minus sine squared x. So keep simplifying. So sine x minus 2 sine cubed of x plus 2 sine of x minus 2 sine squared x. We get 3 sine of x minus 4 sine cubed of x. Right, okay. Hence or otherwise solve for 0 to 360 theta equation 2 sine 3 theta equals to 5 sine 2 theta, right? 2 sine 3 theta equals to 5 sine of 2 theta. Just to make sure that that's what we had over here. Right, okay. So sine 3 theta, 3 sine theta minus 4 sine cubed theta equals to 5. Sine 2 theta can be written as sine 2 sine theta cos theta. Okay, so basically this 2 and this 2 can get cancelled out. Right, okay. So if we see that if we take everything on one side, so you have 4 sine cubed theta minus 3 sine theta plus 5 sine theta cos theta equal to 0. Right, okay. Let's not panic. So 4 sine cube goes on the other side, 3 sine theta becomes negative. Right, okay. So now we can, if we factorize out sine theta, you get 4 sine squared theta minus 3 plus 5 cos theta equal to 0. Right, okay. So either sine theta is equal to 0, or this thing can become 4, 1 minus cos squared theta plus 5 cos theta minus 3 equal to 0. Okay, let's continue. So this becomes 4 minus 4 cos squared theta plus 5 cos theta minus 3 equal to 0. So this becomes minus 4 cos squared theta plus 5 cos theta, and 4 minus 3 is plus 1. So this can be written as 4 cos squared theta minus 5 cos of theta minus 1 equal to 0. Now we need to solve these two equations. So when sine theta is equal to 0, so theta is either in between 0, wait a second, is it in degrees? Right, okay, 0, 180, 360 degrees. So for this one, we need to solve the quadratic equation that it gives us. So the cos theta, because this cannot be done by sum product rule, so you have minus b plus minus b squared minus 4ac, so minus 4 times by 1. This is also negative, so right, 2 times by 4, right. So you have 5 plus minus 25 plus 16, 41 over 8. Okay. Right. So we need cos inverse. This is okay. Cos theta is either 5 plus root 41 over 8, or cos theta is 5 negative root 41 over 8. So let's see which we have. So cos inverse 5 plus root 41 divided by 8. I was like 8. So right, so basically this value is not giving us any solutions because this is going above 1. If we do the minus, yes, then we get a value 100.1. And this is the obviously the negative value, so we will have another one also. How do we know this? There are two ways you know this. There's a graph thing. The graph is crossing at 100. This is 180. So 180 minus 100 and 180. No, sorry. This is 100. So and this one is 360 minus 100. So 360 minus 100.1. Okay, and 360 minus that. So 100.1 and 2, let's say 259.9. Right, okay. And we also had the 180 and 360 degrees, so only 0 is not included. Okay. So therefore theta would be 100.1, 180 degrees, 259.9 degrees, and 360 degrees. Those are our answers. Okay, so this is for this question. Let's move on to the next one. Question number 6. The function f and g are defined by 6 minus 21 over 2x plus 3, where x is greater than or equal to 0, and g of x is x squared plus 2. Find g f of 2. Right. So basically first we find out f of 2. This is going to be 6 minus 21 over 2 times by 2, 4 plus 3. 21 divided by 7 is just 3, so 6 minus 3 is 3. And now we plug this into G. So 3 squared plus 5, so 9 plus 5 equal to 14. Now find f inverse of x. Okay. First we write it like this, 21 over x, 2x plus 3 . Okay, and what we can do, one neat way of handling this is we multiply both sides by 2x plus 3. So we get 2x plus 3 times by y equals to 6 times by 2x plus 3 minus 21. We will get 2xy plus 3y equals to 12x plus 18 minus 21. All the x terms on one side. 2xy minus 12x equals to 18 minus 21, which is also 3. Now x would be 2y minus 12 equals to minus 3y plus 3. So x would be minus 3 y plus 1 divided by 2 y minus 6. Now so this would become, wait a second, was this G or F? F, okay. This can also be written as like 3y plus 1 if you multiply the minus. So this can be further written as f inverse of x equals to 3x minus 1, 2, 6 minus x. That is your f inverse. Solve the equation g of x equals to 126. Okay. Let's figure out how to do this. So g of x is x squared plus 5. g of x would be x squared plus 5 whole squared plus 5. Let's simplify this. X raised to power 4 plus 10x squared plus 25 plus 5. This would be x raised to power 4 plus 10x squared plus 30. And we need it for 126, okay? So x raised to power 4 plus 10x squared plus 30 equals to 126. So simplify, take 126 on this side. 30 minus 126 is minus 96. Okay, now this is a quadratic equation. We can solve it for example, z is equal to x squared. So z squared plus 10z minus 96. Right, so x squared or z can be written as minus b plus minus b squared minus 4ac 4 times by 96 divided by 2. So minus 10 plus minus 100 plus 4 times by 96, 484. Square root of 484 is 22 divided by 2. So x squared is either minus 10 minus 22 divided by 2, or it is minus 10 plus 22 divided by 2. So it's either minus 32 over 2, which is minus 16, or it is 12 over 2, 22 minus 10, 12 over 2, which is 6. This cannot give us any solution because no square value can be negative. However, this can, so x would be plus minus root 6. Right. Alright, so let's move on to the next question. Question number 7. The curve C has equation y equals to f of x, where f of x is x cubed over x plus 7 square root. Show that f prime of x is this. Right, okay, so we will consider it as a product of two functions. X cubed for x plus 7. I hope I noted it down correct. Right, a part. So we can also write it as x cubed times by 4x plus 7, 1 over 2. Right. Okay. So let's say u is x cubed. U prime would be 3x squared. Oh, sorry, actually we can write it over here. If x cubed, u prime would be 3x squared. And if v is equal to 4x plus 7, 1 over 2, v prime would be 1 over 2, 4x plus 7 minus 1 over 2 times by 4. So this would be just 2 4x plus 7 minus 1 over 2. Right, okay, so f prime of x would be u v prime x cubed times by 2 4x plus 7 minus 1 over 2 plus 3x squared 4x plus 7 1 over 2. Right, in what form did we require this? 2x plus 3. Okay, let's figure out how we are actually getting 2x plus 3. So you have 2x cubed root 4x plus 7 plus 3x squared root 4x plus 7. Wait a second, let's see again. Okay, so what if we divide this by root 4x plus 7 and times it by root 4x plus 7? So we will get square root 4x plus 7, 2x cubed plus 3x squared 4x plus 7. This will simplify to be 2x cubed plus 12x cubed, 14x cubed plus 21 x squared, sorry, 4x plus 7, and again x squared, right? Okay, so 7x squared, basically 7x squared, so this would be like 2x plus 3 square root 4x plus 7. Right, is it 2x plus 3 or 3x plus 3? Right, 2x plus 3. Okay. Point P shown in the figure 3 is the minimum turning point on C. Find the coordinates of P. Okay. So part B is where f prime of x is 0. So basically the bottom part we don't have to worry about. So x squared, 7x squared, 2x plus 3 equal to 0. So either x is 0 from this, or x is 3 minus 3 over 2. So x is not 0, obviously, and this would be 3 over 2. But we do need to check whether, right, yeah, so basically 1.5, yeah, that would be available. Okay, find the coordinates, so we need the y part also. X cubed 4x plus 7. Four x plus 7, 1 over 2. So this would be minus 27 over 8 minus 6 plus 7 is minus 1. No, 1. 7 minus 1. 1 raised to power 1 over 2 is that. So minus 27 over 8. So minimum point P is x is equal to minus 3 over 2 and x equals to minus 27 over 8. Right, okay. Hence find the range of the function g defined by g of x minus 4f of x. Okay, so basically first we need to figure out what's the range of f of x also. So range of f of x is all greater than this, right? So C part, f of x is greater than equal to minus 27 over 8. For f of x would be greater than minus 27 divided by 8 times by 4, 27, minus 27 over 2. When you do the minus minus, this will become f of x less than equal to 27 over 2. So the g of x is less than 27 over 2. Okay. The point Q with coordinates 1 over 2, 3 by 8 lies on C. Find the coordinates of the point to which Q is mapped when C is transformed with equation this. So this is straightforward actually, so not that big of a deal. So if f of 1 over 2 is 3 over 2, that was it, right? Yeah, 3 over 8, sorry, 3 over 8. So we need, when it goes to 40 x minus 3 over 2 minus 8, just to make sure that this is what we have. Minus 3 over 2 minus 8, right, okay. So this is the translation, or this is the transformation happening for x, right? So basically we need the same value back, correct? So x minus 3 over 2 equals to 1 over 2, so this would be x is equal to 2. So that way basically we're getting 1 over 2 back again. Now the 3 by 8 value, you see f of this value, which is now going to be 3 by 8, is now multiplied by 40, then minus 8. So y value is 40 times by 3 by 8 minus 8. So 8 times by 5, 15 minus 8. 15 minus 8, 7. So the point is going to be therefore 2, 7. And that is your question number 7. Let's move on to the next question. Question number 8. The heart rate of a horse is being monitored. Heart rate h measured in beats per minute is modeled by the equation this, okay, where t minutes is the time after monitoring began. Figure 4 is a sketch of h against t. Use the equation of the model to answer parts A to E. State the initial heart rate of the horse. That means when t is equal to 0. So when t is equal to 0, e raised to power 0 is 1 basically. So heart rate is equal to 32 plus 40 e raised to power minus 0.32 t, is it plus? Minus 2t, sorry. Okay. And minus 20 e 0.9t, right? Let's just hope I did not make any mistake. Again, 40 e raised to the power minus 2t and 20 e raised to the power minus 9t. Okay, so that means at t equal to 0 would be 32 plus 40 minus 20, because e raised to the power 0 is just 1. 32 plus 40 minus 20 is 52. Right, okay. In the long term, the heart rate of the horse approaches L beats per minute. State the value of L. Okay, so when you have this approaches to 0 as x approaches infinity. So it would approach 32. Okay, so as x approaches infinity, e raised to power minus x approaches 0. So therefore h when t approaches infinity, h would approach 32. So it would become L would be 32. Okay. The heart rate of the horse reaches its maximum value after t minutes. Find the value of t given your answer to 3 decimal places. So maximum value, so basically we need to differentiate this. So dh over dt. So 0 minus 0.2 times by 40 e raised to power minus 0.2t, and minus 0.920 e raised to power minus 0.9t. So we are getting 0.2 times by 40, 8, e raised to the power minus 0.2t, and 0.9 times by 20, 18, e raised to the power minus 0.9t, and this is equal to 0. Okay, so therefore 18 e raised to the power minus 0.9t is equal to minus 8 e raised to the power minus 0.2t. So e raised to the power minus 0.9t divided by e raised to the power minus 0.2t equals to minus 8 over 18. This becomes e raised to the power minus 0.9t plus 0.2t equals to 3 over 9. No, 4 over 9. Okay, so this would become e raised to the power minus 0.7. T equals to minus 4 over 9. So ln on both sides. No. There is some problem over here. This was the one minus. There was a minus sign. So this would become basically plus. So plus. Alright. So now we take the ln. So minus 0.7t equals to ln 4 minus ln 9. So t would be ln 4 minus ln 9 divided by minus 0.7. So ln 4 divided by 9 divided by minus 0.7. So this is 1.16. Okay. 3 decimal places. Okay, so 159, let's say. Okay, 3 decimal. 158 was the correct one. Right, okay. The heart of the horse rate, sorry, the heart rate of the horse is 37 beats per minute after m minutes. Show that m is the solution of equation this. So let's plug it into this equation given. So at heart rate, this is part C or part D? Part D. Okay. So you have 32 plus 40 e raised to power minus 0.2 m minus 20 e raised to power minus 0.9 m equals to 37. Actually, we can let's keep it as t. Okay. Right. So 37 minus 32 is 5. So this would become 40 e raised to power minus 0.2 t minus 20 e raised to power minus 0.9 t equals to 5. Divide both sides by 5. You will get 8 e raised to power minus 2t minus 4 e raised to power minus 0.9t equals to 1. How did we want it? So 8 e raised to power 0.82t 1 plus 4 e raised to power minus 0.9t. Wait a second. Is that what's under? Right. Yeah. We'll figure this out in a second what this means. Let's take ln on both sides. 8 plus minus 0.2 t equals to ln 1 plus 4 e raised to power minus 0.9 t, right? Okay, and 0.2 t would be ln 8 minus ln 1 plus 4 e raised to power minus 0.9 t, right? Okay, now it's shaping it up. 0.2 is 1 over 5, therefore t would be 5, and we can turn this into a fraction. 8 divided by 1 plus 4 e raised to power minus 0.9 t, and therefore we convert it into like this: 5 ln 8 over 1 plus 4 e raised to power minus 0.9 tn. Let's hope this is what it is. Yeah, okay. Right, t1 equals to 10. Find 4 decimal places the value of t2. So t1 is 10. t2 would be 5 ln 8 1 plus 4 e raised to power minus 0.9 times by 10. 10, you get 5 ln 8 divided by 1 plus 4 e raised to power minus 0.9 times by answer. We needed up to how many decimal places? 4 decimal places. 10.3947. Wait, m do we need in 4 decimal places also? That means we need to check up until 5 decimal places. Okay, so we carry on. And now it's wait a second. If this is, let's say, 10, we get this. Okay, now if instead we have answer 395, 10.395 477, so basically 8. Okay, so 10.3947, so 39548. Okay, so 395477. Then you get 10.395478, that is 8. Okay, then we do 4789 789, we get 10.3954. So basically the values are becoming stagnant, so therefore m is 10.3955. Okay, so that's it for this question. Let's move on to the final and the 9th question. Question number 9. Figure 5 shows a sketch of the part of the curve C with equation y equals to f of x, where f of x is 6x squared plus 4x minus 2 divided by 2x plus 1. Find f prime of x, giving your answer in simplest form. So basically we need to do quotient rule. Six x squared plus 4x minus 2 divided by 2x plus 1. Okay, so u is going to be 6x squared plus 4x minus 2, so u prime would be 12x plus 4. V is 2x plus 1. V prime would be 2. So f prime of x, vu prime. So you have 2x plus 1, 12x plus 4 minus uv prime, 2, 6x squared plus 4x minus 2 divided by 2x plus 1 whole square. Right, okay, let's further simplify this. So this is going to become 24x squared plus 8x plus 12x plus 4. 8x, right, okay. So then this becomes minus 12x squared minus 8x plus 4 divided by 2x plus 1 whole squared, okay. So as you can see, some items can get cancelled, 8x, 8x, right. So we are getting 24 minus 12, 12x squared, 12x plus 8 divided by 2x plus 1 whole squared. Okay, that's a part. The line L is normal to C at point 2, 6. Show that the equation for the line L is this. Okay, first off we need the dy by dx, or f prime of x at 2. Okay, so P is 2, 6. Okay, so f prime at 2 would be 12, 4 plus 12 times by 2 plus 8 divided by 2 times by 2 is 4, 4 plus 1, 5 squared is 25. So 48 plus 24 plus 8, 80 divided by 25, 16 over 5. So gradient of normal is equal to minus 5 over 16. So equation of normal would be y minus y1 equals to mx minus x1. So y minus 6 minus 5 over 16, x minus 2. So 16y minus 16 times by 6, 96, equals to minus 5x plus 10. So this becomes 16y plus 5x minus 106 equal to 0. Let's hope this is correct. Yeah, okay, equals to 106, okay. Equals to 106. Right. Okay. Right. Now what do we need? Write f of x in the form ax plus b d2x plus 1. Okay, so first we need to do the long division. Right. C part, long division. So this was 6x squared plus 4x minus 2. 6x squared plus 4x minus 2 and 2x plus 1. Right, okay. First off, 3x. So this would become 6x squared plus 3x minus x minus 2. So I don't think we can do anything further than this. Yeah, okay. So this would be 3x plus x minus 2, 2x plus 1. Actually, we can still. Wait a second. Did they say this is d? D is a constant. Okay, d is a constant. No. We need to go further. Okay, we need to go further. So this is x minus 2. So this would be, let's say, half. This would become x and minus plus 0.5. So minus. So this is minus 2.5. Right. So this is our final form. So this is your 3x plus half minus, let's say 5 over 2, 2x plus 1. Right, okay. Right, now what do we need to do? That was the C part. Okay, alright. The region R is shown shaded in the figure 5, is bounded by C, L, and X axis. Use algebraic integration to find the exact area of R, giving your answer in the form P plus Q ln 3. Okay, so you see this is at X is equal to 2. So we need the area from, we need to figure out where this is also. Right, so 6x squared plus 4x minus 2, we need to figure out the roots for this. Okay, this would become 3x squared plus 2x minus 1 equal to 0. So this is going to be easy. Minus 1, 2x, 3x squared, minus 1 plus 1. So 3 minus 3x minus x. Right, okay. So either x is 1 over 3 and our x is minus 1. There's a minus 1 over here. Okay, so, okay, alright, okay. So this is not strictly quadratic, no? This is not strictly quadratic. Right, okay. So this is our 1 over 3 and this is to 2. And this is basically the area under the line from 2 to whatever this is, but we can treat it as a triangle also. However, we still don't know what this width is. Right, okay. So D part, integral from 1 over 3 to 2 f of x dx plus from 2 to, we have, we just need to plug in x is equal to 0 over here. So when we plug in x is equal to 0, we get 16y equals to 1 over 6. So 1 over 6 divided by 16, this is 53 over 8. This is a weird thing. Sorry, what am I doing? Y is equal to 0. Wait. Y is equal to 0. So y is equal to 0, 106 divided by 5. Right, okay, so x would be just simply 21.2. Alright, so 21.2. 21.2. Right, okay. What was it? Minus 5x (106) divided by 16 dx. Basically the area of that. Okay, the major problem is going to be over here. So like the integral of 3x plus 1 over 2 plus minus 5 over 2 1 over 2x plus 1 dx. First, let's figure this out. Plus half times by 6 times by 21.2 minus 2. 1 over 3, 2. Okay. So 3x, so this becomes x squared over 2 plus half x. Now we need the integral of this. We need to multiply this by 2 times by 2 to make it ln. So this becomes minus 4, 5 over 4 ln 2x plus 1 from 1 over 3 to 2 plus 3 times by 21 minus 2 is 19.2. Okay. 3 over 2 times by 4 plus half of 1 half of 2 minus 5 over 4. 2x plus 1 is ln 5. 1.5 divided by 9 is 1 over 6. Wait a second. First let's write it. 3 by 2, 1 over 9 plus 1 over 2, 1 over 3, and minus 5 over 4 ln 2 over 3 plus 1. Plus 3 times by 19.2, 288 over 5. Okay. 12 divided by 2 is 6 plus 1 minus 5 over 4 ln 5 minus 1 over 6, 3 plus 1 over 6 again minus 5 over 4 ln 5 over 3 basically. 3 times by 3, so 5 over 3 plus 288 over 5. Right, okay. 7 minus 5 over 4 ln 5. 1 over 6 plus 1 over 6 is 1 over 3, so minus 1 over 3 plus 5 over 4 ln 5 over 3. Actually, this should be mod over here. No. It's fine. Okay. The value is fine. Brackets is fine. Plus 288 over 5. Right. So 7 minus 1 divided by 3 plus 288 divided by 5. 964 over 15, and 5 plus, wait. You have plus 5 over 4 ln 5 over 3 minus ln 5, right? Ln 5 over 3 minus 5 over 4 ln 5. So basically this is 5 over 3 divided by 5. So 964 over 15 plus 5 over 4 ln 5 over 3 divided by 5 is basically 1 over 3. And ln 1 over 3 is just minus ln 3. So 964 over 15 minus 5 over 4 ln 3. Right, I think that's the last part. Yes, thankfully, this is the last part. And that's the end of this paper. Hopefully you enjoyed this paper and the explanations we were given. If I made a mistake or missed anything out, please reach out in the comments. If you have any confusions or doubts, also reach out in the comments so I can help you. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Until next time, we will see you in the next video. Meanwhile, take care.